Okay, Algebra 1, we are halfway through 3.5, and we're going to finish the second half today. We've got like 3 examples left. We may do some of the checks, though. We'll see. But we, yesterday, just to kind of recap that, we talked about 3 different things, okay? I'm going to go right here and recap those 3 different things. So the first one was line symmetry. And that is like if you have a lot of them were parabolas that we had, and we would find where that line of symmetry was located. Like, so let's say this point right here is 4. That would be a line of symmetry at x equals 4. That's our line symmetry. It's dividing that parabola in half. The second thing that we talked about was where a function was increasing and where the function was decreasing. So if I use the same graph right here, it's not a very good graph. Let me draw it a little bit better. Okay, let's say my parabola is doing this, right? Because if he's truly symmetric, that's still not very good. But anyway, what's happening is this function is increasing from here until it gets to this point, right? And so we divide it off with the x coordinates. So we have 4 right here. Everything on this side of 4 is where he is increasing. He's going uphill, right? So he's increasing for all x's that are less than 4. Okay, and then what he's doing is he's turning around and he's decreasing after we touch 4. So on this side of 4, he's going to be going downhill, which means as the x's are greater than 4, he's decreasing. Okay, so increasing, decreasing, that was another thing that we talked about yesterday. And then the third thing was we talked about maximums and minimums. I'll say max and min, and these are called extrema. Okay, and they may have used the word relative, relative max and relative min, and that's just in relationship to the points around it. What is it doing? So if we're talking about this graph right here, we have only 1, and it is a relative maximum, and it is there at this point. Let's say that is the coordinate 6 right here. So we would say he has a relative maximum at 4, 6, and he has no relative minimum, okay, because he doesn't have a low point per se. Okay, so those are the 3 things just kind of in summary that we talked about yesterday. We're adding one more thing to this today. Okay, and it is actually, we got to do example 5 first, which has to do with extrema. So we'll add the 4th thing here in just a second. Okay, this one's interpret extrema of the graph of a function. It says a comic book store uses a function to model its profit. Okay, in thousands of dollars, give the price in dollars that it charges for individual issues. Determine whether point D is a relative min, a relative max, or neither. Then interpret its meaning. Okay. Oh, that it charges for individual issues. Determine whether point D is a relative max or min. So D right here is going to be a relative max, because all nearby points have lesser y coordinates. So on this side it tapers off, on this side it tapers off. So it's a high point at D. That should be pretty easy to figure out. And then it says point D represents the blank that the comic book store can earn given the price it charges per issue. The maximum, let's see, profit. I'll say maximum profit that the comic book store can earn. Okay, so at this point it is at the highest profit value. So if it charges, so like this is how this works, right? If it's only charging $2 an issue, right, it has a point right here, $2 an issue, it's earning I don't know, like $55, right? But that is like in thousands of dollars. So it's earning $55,000 because you're not making as much money, because it is like you're not charging as much, but also you're probably selling more. So that kind of plays into it. Over here, we're making the same amount of money because we're selling less copies, but we're charging more for each copy. We're charging $6 for each copy. So that's the reason why that one. So typically what happens is the more this goes up, the less people buy, but they're buying it for a higher price. So the profit is still doing kind of one of these motions, right? Okay. So those are kind of the 2 variables that are into play. It's like a supply and demand type of thing. Okay. So the maximum profit occurs when I charge $4 per issue. So I charge $4 per issue, there's a lot of people buying them, and it's going to maximize my profit, okay, at about like $78,000, something like that, okay? So there is that. I think I'm going to skip that check. Let's go to the fourth thing, which is something called end behavior. behavior. Okay, end behavior. Okay, and so basically, end behavior is the behavior that a graph is doing at the ends of the graph, right? End behavior at the end of the graph. So at one end of the graph it's doing this, and at one end of the graph it's doing this. It's like what's happening at the arrows on either end, right? Okay, so every time you do end behavior, they don't teach this to you in your Algebra 1 book, but I'm going to teach the notation that you use in Algebra 2 to make it easier for you guys next year. The end behavior we set up in this pattern, and you will fill this out every single time. Okay, so write this down. X with an arrow and infinity symbol, Y an arrow, and we're going to put a blank. X with an arrow, a negative infinity symbol, Y with an arrow, and we're going to put a blank. Okay, so write that down, and every single time they ask for end behavior, I want you to fill this in. Okay, so we're doing this a little bit different than they're asking for in this class or in this section. We're going to use this notation though, because that's what you guys use in Algebra 2. So I'm just preparing you for that. It's not a terrible notation. So write this guy down up here in the corner so you can refer back to him. Okay. And so what this is saying is x's. Okay. X's go left to right. And as we're going toward infinity on the x, so let me draw a graph right here. As we're going toward infinity, infinity is a really large number for x. Really large numbers for x are on the right. So this is basically like saying as the graph is going to the right. Okay, and what we're going to do is we're going to say, like, what is the y coordinate doing, right? Y's go up and down. So if it's going down, then that means you're going to put negative infinity in this blank. If it's going up, you're going to put positive infinity in this blank, right? Okay, and then the second line says this: as x goes toward negative infinity, x's again go left and right, and negative infinity is going to be negative numbers over here. So this is a fancy way of saying as the function goes to the left, or as your graph goes to the left, what is happening with the y's? Is it going up or is it going down? So every time you have an end behavior question, you're just going to write that out, and you're going to fill in the blanks for x for your y's. Okay. So let's do an example of that, and that is, I don't know, let's do this one. Determine the end behavior. Now, they just talk about it as increasing, decreasing, whatever, but I'm going to go ahead and I'm going to have us fill in that format. So as x goes toward infinity, the y is doing something. As x goes toward negative infinity, the y is doing something. Okay, you're going to fill that out every single time. You're going to fill out that end behavior. Positive infinity, negative infinity, okay? Now, we're looking at this graph right here, and we're saying x going toward infinity. X's are left and right. And infinity, positive infinity would be over here. So this is a fancy way of saying as we're going to the right, right? That's what I just said. As we're going to the right. So as this graph is going to the right, on the right side of the graph, what's happening as he's going? Is he going up or is he going down? Well, he's going up, so that means the y's are going toward infinity, right? Okay. Now this one, as x's go toward negative infinity, x's go left and right, so negative infinity would be going to the left forever. So as my function goes to the left forever and ever and ever, this is going down, so that means we're going to put negative infinity in that blank. And this is what the end behavior looks like, okay? All right, so you're just filling in this pink piece, and you're writing what the y coordinates are going to do. Let's do another one of those, okay? Let's do the end behavior for this check. So as x goes toward infinity, the y is going towards something. And as x goes toward negative infinity, my arrows don't look very good, the y is going towards something, okay? All right. I'll give you a second to write that down for just a second. This is the check. This is another linear function, by the way, again. The first one was a linear function as well, okay? All right. Yeah. All right, here we go. So as x goes toward infinity, x is going toward infinity, or going to the right. So that's a fancy way of saying we're going to the right, right? Like we know that. The y is going up. So he's going toward infinity as well. As x goes toward the left, or toward negative infinity, the y's are going down. So he's going toward negative infinity as well. okay? They just have as x increases the y, blah, 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 as x decreases the y, decreases whatever, right? But that's the same thing, but just in symbol format, right? Okay, so I want you guys to get used to doing it this way because that's what you'll do in Algebra 2, and it'll just make it way easier next year when you do that, okay? So rather than teaching you two different ways of doing the same thing, let's just teach you the one way, right? So there's that, okay? Now, will they always go opposite directions? Like these two right here, like the y coordinates, will they always go opposite directions? Well, let's think about this. A parabola that we've been talking about, right? Those are going to go the same direction, right? So if I have something that looks like that, as we're going to the right, this function is going up, so that's true. But as we're going to the left, it's also going up. So if this was the end behavior, if this was the graph, this parabola, it would actually be infinity and infinity for both of them. They would not go opposite directions. So the end behavior will change just a bit when you have a parabola versus when you have them going opposite directions, okay? All right, let's do an example of that down here. Determine the end behavior of a non-linear function. So this is this guy. This is actually the graph of y equals x cubed. I know I've talked about him before. You don't have to know that, but that's kind of how that works, okay? We're going to fill in our end behavior. So as x goes toward infinity, y is doing something, and as x goes toward negative infinity, y is doing something, right? We're just going to fill those blanks in, okay? X goes toward infinity means to the right. We've written that like 4 times already, okay? So on the right side of my graph, it's doing this right here. It's going up. So the y is doing infinity, okay? This is a fancy way of saying to the left, as x goes toward negative infinity, that's x is going to the left forever. He is going, the left side of my graph is going down, so he's going toward negative infinity, okay? That's another one where they're going opposite directions, right? But we're going to see one here in just a second where they're going the same direction. So this check, let's do this one real quick, okay? As x goes toward infinity, the y is doing something. As x goes toward negative infinity, the y is doing something, okay? All right, x go toward infinity means on the right side of the graph again, right? What's he doing on the right side of the graph? He's up here, so he is going up, which means toward infinity. Infinity is up, right? Infinity for x's are right, infinity for y's are up, okay? As x goes toward negative infinity, this is left, because negative infinity on the x is left. He is going on the left side of the graph. He's also going up. So this is the first case that we've had both of these be the same because they're both going the same direction, okay? All right, let's do the bottom one. This is a parabola. So as x goes toward infinity, the y is doing something. As x goes toward negative infinity, the y is doing something. We just got to fill the blanks in, right? This is on the right side of the graph. X is toward infinity is the right, okay? As he goes to the right, he is going up. So that's infinity as well, okay? As x goes toward negative infinity, which means to the on the left side of my graph, he is going up as well, okay? So toward infinity. This is the end behavior for that one. This one's end behavior actually had the same end behavior as this one, right? It's up and up, right? And up and up. So those two end behaviors, even though the graphs in the middle will look the same, we're not talking about the middle, we're talking about the ends, right? The left, the forever to the left, forever to the right. The ends, right? We don't care about how many humps he has in the middle, whatever. We'll deal with that later, right? But on the end points, what's happening, okay? So when you have that on your homework assignment, I want you to fill it in and just start off with that piece. X goes toward infinity, y, and then fill in the blank. X goes toward negative infinity, y, fill in the blank, okay? Every one of those, all right? Your homework assignment will be 15 through 22 all, okay? So that is the, I don't know, the back page? No, you've already had to do, let's see, you already had to do 1 through 14 for homework. So 15 through 22 is just these problems and then these two right here. And 21 and 22, let me focus your attention on those. They're asking you lots of things, okay? So I'm going to fill that in real quick, okay? The first thing they ask you is whether it has a line of symmetry. Line symmetry, okay? And where the function is increasing and where the function is decreasing. And they want to know the extrema, so they want to know relative max, relative min, and then they want the end behavior. So as x goes toward infinity, the y is doing something. As x goes toward negative infinity, The y is doing something, okay? So you're filling all of those in for each one of those. So recopy this and put it over here as well, and you can fill those in for 21 and 22. It's analyzing all of that for every function, okay? So 15 through 22 evens, or all for those, and that is it.